Good afternoon, Devoxx. Thanks for being here. Thanks for visiting. My name is Maarten Mulders, and in the following 3 hours, we're going to cover React Native. I work at a Dutch company called InfoSupport. We do consulting mainly. We do enterprise mobile development as well. We've built the mobile app that all train personnel in the Netherlands uses to validate train tickets, see what train they have to drive next, what kind of delays there might be, etc., etc. So let's get started. If you're Dutch like me, and if you're around the same age like me, you might recognize this. Who does recognize this, by the way? Just to get an idea. Oh, quite some hands, thank you. This is a TV show that aired when I was young, 20 years ago maybe. The guy in the middle was presenting the game. His name was François Boulanger. Many people believed he was actually Frans de Bakker, which is just a literal Dutch translation. But he has always assured that his real name was François Boulanger. Anyway, you were playing the game in 2 teams and you had to guess words. It's that easy. And to make it a little bit easier even, you would get 1 letter for free, like this. So, for example, we would have to guess a word of 5 letters, starting with the B. Now, there could, of course, be a lot of words starting with B, so we just would think of 1 word and we would need to spell that word out. So we would be like, well, maybe the word is beast. That's B-E-A-S-T. And then you would get this. And that says the B is in the word that we're looking for. And it's on the right spot as well. So is the E. It's on the right place. There's no A in the word. There is an S, but it's not on this place. And there's no T. Well, a second guess might be bogus. I'm really out of clues already. And the computer would tell us that the S is on the right spot this time, but none of the other letters are actually in the word. Okay, well, berry maybe. And now we would see that we have this new letter R. We didn't know it was in the word yet, but now we know. And then finally, light bulb emerges. We're in Belgium, of course. The word is beers. So it's actually a very simple game, as you can see. There's no heavy graphics involved. There's no very complex screenplay whatsoever. And it was this game that I wanted to be able to play on my mobile phone. And, well, since I'm a developer, I figured I could build it myself. And it might be a nice use case to get started with React Native. Now, if you want to get started with React Native, you have to do 2 simple things. First of all, you need to have Node and Node.js and the Node package manager installed, of course. And then you start with installing the React Native CLI. And the React Native CLI is the tool that you use when building, running, etc., your React Native application. And once you have half of the internet installed, downloaded to your machine and installed, you would issue a new command, which would be React-Native init React Native demo. That latter parameter is the name of the app that you want to create. Again, you would need to wait for some minutes, and then you would be seeing some output like this. It would say something like, okay, if you want to run your application, you need to go to a specific directory and issue React Native run iOS, or you could open the project in Xcode, or you could run React-Native run -Android. So there's quite some options. You can use the CLI, or you can use the IDE of your choice. Obviously, if you want to run applications on your iPhone, you need to have a MacBook or an iMac. You would still get this output if you're on a Windows machine, probably, but it just will not be able to work because you don't have Xcode or all those tools. But I do have a MacBook, so we can play around with that a little bit. I'll save you the 5 to 10 minutes wait of installing all this stuff. I've did that beforehand. And here with me I have an Android device and an iPhone, so we can see what the result looks like. After you've done that, let's see. This is the Android device. Oh, I shouldn't rotate it probably. Here's my app running. Welcome to React Native, it says. And well, you can probably better see it on the big screen over there. And the same holds for the iOS device. It has the same welcome screen, welcome to React Native. And it also says to get started, edit app.js. And then on Android, which is on the right, you can see that you should double tap R on your keyboard or shake or press the menu button. If you were in early, you would have seen me doing this frantically. That's not because I hate my phone, but it's because it turns up the development menu. And using the development menu, I can do quite some nice features. I can trigger a reload of the JavaScript bundle, for example. I could say enable live reload, so that once I update one of the code files, it will immediately be pushed to my device, and I can see what it does. And I can have the performance monitoring. I can have an inspector to see where all my elements reside, and I have some development settings that I can go through to specify how I want to connect to my MacBook, for example. And on the iPhone, it's pretty similar, except that it says press Command R to reload, or shake for dev menu. Well, let's see. Yeah, also works on iPhone. Brilliant. Reload. As you can see, there's a small green bar over there that indicates the files being reloaded. And we'll say live reload as well. Now, if we go to the application, there's an app.js. And as we saw here, it says edit app.js to get started. So that's one thing we can do. We'll save it. And at least the iPhone was updated. The Android device wasn't, for some particular reason. It's also updated. I don't know, did I turn it off, maybe? Enable hot reload. One more try, just to be sure. We'll add an extra exclamation mark over there. That's better. So as you can see, I'm updating my code and I can see the effect on my application immediately. One of the things I particularly love about React Native is its very fast feedback cycle. If you were used to building native applications using Android, or using Java or using Objective-C or Swift, you would have to rebuild your whole application, create a new APK, in the case of Android, or a new .app file in the case of iOS, push that to your device, restart the application to finally see the effect. And here, especially if I'm having the live reload on, I can see it immediately. If I do not have live reload on, I don't see it immediately, but I can simply shake my device, press reload, and I'm done. Well, you might say that's awesome, thanks for this, but we have 3 hours to cover, so there's a lot more to say about this. First of all, a question I often get is how does this compare to other cross-platform application platforms? For example, there's Cordova or PhoneGap, which is more or less the same name for a different name for the same thing. Well, if you take a look at Cordova or PhoneGap, you'll see that it uses HTML, JavaScript, and CSS. In fact, it will create a web application for you, and it will create a very small Android or iOS application with just a web view in it. And the web view will in turn run the web application. So in fact, if you can't run Docker on your device, you can have other containerization technologies. And in this case, the containerization technology is actually a web browser, and the application runs inside the web browser. The web browser runs on your device. So I'm not saying it's a bad thing, I'm just saying it's a different thing. Another popular one is Xamarin. It got especially popular since Microsoft decided to open source it, so you don't have to pay big license fees to get started, even, let alone to run it in production. For Xamarin, you write your application in C#, which to me as a Java developer, I have to be honest, it's quite a big hurdle. I don't know C#. I don't know if I want to learn it. Maybe I will, But just to get things started, well, to me, it's quite an effort. And as soon as you start deploying your application, you will have to include a Mono runtime. Mono is the open source implementation of the .NET standard, the .NET platform. And it will be packaged with your application so that your application can run on both platforms. The good thing is it's a native application, so there's nothing like a web view with a web application inside. It's just all native UI elements. But, well, C# might be a problem for you. It might not be. But at least we know the differences between the platforms. Now, let's look at React Native. If you visit its webpage, you're greeted with a nice marketing summary, one-line summary. React Native lets you build mobile apps using only JavaScript, and it uses the same design as React, letting you compose a rich mobile user interface from declarative components. Awesome. It also determines the agenda for the rest of this talk, because we'll have to look at two main things. We have to look at how React works. In order to understand how React Native works, we need to understand React. And then, once we know that, we can have a little break, grab some coffee or tea or whatever, and then we'll dive into building mobile apps using that. Now, React Native, some people say, well, it's new, it's how well is that supported? Am I on my own, maybe, if I want to use that? Well, you're not on your own, first of all. React Native was created at Facebook. They've decided to open source that. First, they open sourced their iOS implementation. Well, that's cool, but it's not cross-platform yet. Then they also decided to open source the Android implementation, and now it gets really interesting. But there's other companies using it as well, like Airbnb, Tesla, Instagram, Skype, and there's many, many more, but they don't fit on one slide. And as we already saw in the very first quick demo, there's quite an emphasis on developer productivity. There's quite a lot of tooling around it, not only live reloading and stuff, but also debugging your application, having UI profilers and inspectors, which you can use to inspect that your app is indeed running correctly. And finally, it's also a framework that allows you to really test your application quite well. And that's a particularly interesting thing. Next to the developer productivity, there's also an emphasis on having code that is testable. And we'll see that later on. So as I said, we first need to understand React. And then the question might be, what is React? Well, going to its website again, because that's where we all start when we are looking for information, we will find that React is a JavaScript library for building user interfaces. Well, that's not particularly useful yet. What can we actually expect from it? First of all, React is declarative. Second, it's component-based. So let's dive into each of these two and see what it actually means. First of all, React is declarative. That means that in React, you're encouraged to define your view, the views of your application, as functions of the state that your application currently lives in. And that means that we have more predictable code because we can easily figure that if this type of state goes in and it looks like this, then that must come out. It's also easier to debug such code bases since they are usually tiny components, and tiny components are obviously better to test and to debug. But there's something more. We also have stateless components, and these are also called functional components. They are more or less the same as regular components, and we'll see the difference in a few seconds. But secondly, React is also component-based. Component-based means we're again encouraged to construct our application as a combination of all kind of building blocks. And the smaller the building block is, the better it actually is. That holds for many programming models. Smaller equals better. The same holds here. If I can construct my user interface from all kinds of small components, makes it easier to reuse, makes it easier to test. And that also means that if my application needs to store some state somehow, that I can encapsulate that state inside a component. So I can make sure that the state is kept at the place where it needs to be. And that means that we can compose our application, as I said, of tiny building blocks that work together to create the end user experience. The nice thing is that if you're coming from an HTML, JavaScript background, and maybe you've done something with jQuery first, you might be aware of the fact that in HTML you can actually pass just one thing, which is text. If you want to pass, for example, a date value, you first create a string out of it, you pass it around in your DOM, and you hope that somewhere in the DOM some component will pick it up and do the correct calculation, hoping that it still is a value that can be interpreted as a date, which can be brittle, of course. Now, if you are going to build your web application using React, you can just pass JavaScript values, structures, object structures. And that's a big plus when comparing to traditional approaches. So let's look at some React web applications. Quick warning up front, React heavily uses JSX as well as ECMAScript 6. If you don't know these, they might feel uncomfortable. What does it do? I don't really understand what this construct does in this language. Don't need to worry. Many people that use React do use ECMAScript 6 and JSX, and they have Babel to convert that into plain old JavaScript that even Internet Explorer 6 might be able to run, if you're lucky. Otherwise, it might be Internet Explorer 8. So let's look at a quick example for that. This is a very simple React component. I've given it a very descriptive name, hello message, because as we all know, we're obliged to start with hello world. So I decided that I should do that as well. You can see that my component is a function. It takes one parameter, which is called props, shorthand for properties, but you can actually name it anything. And it will return a div element. And no, I did not forget the quotes around this. I am returning a div element here. That's JSX. JSX allows us to use XML, in this case HTML, but it's, of course, that's also XML, to use XML as if they were values in my JavaScript program. And inside the div, I'm having a little text. It says hello, followed by brackets, props.name. So I'm assuming that my props, I don't know exactly what it is, but it appears to be some kind of JavaScript object, and it might have an attribute called name. I have another component, which is called app. App is a function as well, which does not take any arguments, and it will return an XML construct. It will return a self-closing tag for the hello message. And it passes one attribute, with the attribute is named name, to make it all easier, and its value is a string literal called Devoxx. And then finally, I need to instruct React to actually mount this, this application, this tiny application of mine, into the document object model, and I do that using React DOM API, and it has a random method. Now, if you would translate it back to JavaScript, it would look something like this. It's a lot more code, first of all. It is more or less understandable. I still have a function, and it still takes props. There's an app, that's also a function, doesn't take any arguments. It returns react.createElement. React.createElement is actually what happens if you use JSX. Then Babel will translate that for you to an invocation of react.createElement. And react.createElement will take care of what actually needs to be done there. Since JSX is not really a standard yet, there's actually just one implementation that does this, which is React. a colleague of mine is working on a hobby project which will not do React.createElement, but will just spit out some HTML, so it's kind of a static site generator, and it uses more or less the same approach, but well, that's really, there's not many implementations around that actually do this. And if we would be running this application, let's see, I think it's here. I have an index, and there's a div inside the index file, which is called root. And as we can see here, it says React DOM.render, the app element somewhere on the DOM. Now, if I would replace that with the component that we just saw, and we would make it a little bit bigger there. We agree with some kind of an error message. Hello message is not defined. Yes, of course. We need to write that one as well. We will be closing the element there. Hello, Devoxx. Not a big surprise, really. If we look under the hood, we would, I hope this is, oh, well, that's actually quite good. It's still the index.html file that we just saw. Nothing has changed there. If we want to really see the magic that goes on, we need to look at the browser inspector. I hope this is readable even if you're back in the room. As we can see here, it has a body, there's a root, there's the div element with the root ID, and as we can see, it has child elements by now. For example, it has two child elements, both of them are text nodes in the document object model. One of them has the text hello space, and the other one has the text Devoxx. So somehow, React figures out that these JSX elements need to be translated to real DOM elements. And we'll get to that later, how that actually works. But for now, just recall that there is some kind of a mechanism that turns these JSX elements that we just saw into real DOM elements. What we see is what we saw here is what's called the functional approach. These components are just functions that take their properties as an input and return some kind of JSX as their output. We could also write them in a class style. Again, ECMAScript 6 provides classes, something that's not in JavaScript as we currently know it. If we would be running object-oriented code in JavaScript, we would do some function prototype hacks, and then we could invoke new function, and we have something that's, well, kind of mimics an object-oriented style, but it's not really object orientation, there's no inheritance, and you would need all kind of dirty hacks to get it really, well, still not perfectly well working, but at least it kind of works. ECMAScript 6, and especially Babel, take another approach. They allow you to write object-oriented code using just classes, and Babel will generate all this boilerplate that takes care of the inheritance and the classes and everything that sits in between. So we, as developers, don't have to worry about that. We won't be introducing new bugs there because we didn't quite understand how object orientation and function prototyping works in JavaScript. We can just rely on a tool doing that for us in a correct way. What we see is a hello message. It is a React component subclass, and it has one method which is called render, and the render method again will return just the div element. And our app that previously was a function as well is now also a full-fledged class that also extends React component, and it also has a render method, and the end of the code base is still the same. I'm not showing what this looks like when you run it through Babel because it's, I think, 2 or 3 slides full of text, and most of them is not really interesting nor really understandable. So let's just skip that for a second. You might be wondering, why would I actually be using this so-called class style? But at first hand, it appears to be more code than it was in the first example. And indeed, it is more code, but we will see why you sometimes need this style as well. But first, in React, data flows in one way. It's very important to keep that in mind. Has anybody been using Angular? I would actually expect quite a few hands to raise, thank you. If you are using Angular, then your data flows in 2 ways, actually. You have your JavaScript object model, or your JavaScript model. You have your document object model, and Angular ensures that these 2 will always be in sync with each other. And as soon as I change some value somewhere in my JavaScript, for example, as a result of a callback being invoked or something happens, maybe a window does a timeout or whatsoever, then not only my JavaScript will be updated, but also the document object model will be updated. On the other hand, if I update my document object model, for example, because I type some text in an input field, the corresponding JavaScript object is updated immediately. And Angular ensures that the 2 will always stay in sync. Now, I'm not here to bash Angular whatsoever, so I'm not going into any disadvantages that might have, that approach, but that's just how Angular works. React takes another approach, and React dictates you that your data should always flow in one direction, meaning that if your application is running, you have 2 ways to model your application state. One of them is props, and the other one is state of a component. As we saw earlier, you can encapsulate state in a React application. You do that inside a component. And these 2, the props with which an element is being rendered and its internal state, they determine together what the element actually does and how it actually renders into your DOM. Now, people often find it hard to tell the difference between props and state. It's pretty simple. Props come from outside, so they are supplied when the element is being rendered on a page or being rendered at all. And for the component, it's as if they were immutable. You can't change them, simple as that. Whereas state is something internal to the component. An outside component can never interact with your state, so it's like private variables, and they are read-write, so you can modify them. And the one way in which data flows is that it flows from top to bottom, or from parent to child, if you wish. Your React application, as we saw in this very simple example over here, starts with a root element. In our case, it's the app. And the app is like the root of the whole application. Well, in this case, it has just one child, so it's not a very interesting application, but it's just to illustrate the example. And the hello message has one child element, which is a div, and the div has 2 child elements. Both of them are DOM nodes of type text. But that might lead you to the question, how do I actually handle user input or any other actions that the user might be doing on my application? Because data flows from top to bottom, from parent to child, where can I hook onto that? And the answer is pretty simple, because it's actually comparable to what you have been doing with other web application frameworks. You just use some kind of a callback or an event handler to react to an event being happening inside your application. And since these are just like regular DOM event handlers, you can do pretty much anything you wish. You can run validation logic on input elements to see whether some kind of value meets the business validations that need to occur. Are you indeed at least 18 years old? Did you agree with our terms and conditions that you didn't read either way? Or they can, for example, update the state of a parent component. That means if I have a component, for example, an input, I could supply it a function as a callback to be invoked when something inside that child element happens to occur. And as soon as that occurs, the function is being invoked. But the function runs in the scope of the parent element and as such can only update the state of the parent component. We'll get to that in a minute, how that actually looks. We can access, for example, browser storage. Most modern browsers have local storage and session storage. We could perform HTTP requests. We could do pretty much anything we like. Now, as I said, we have two ways of writing components. We can write them as a function in a more or less functional style, and we can write ECMAScript 6 classes. And why would you actually be doing that? Well, this is a very simple example. We'll just take a look at it in the IDE, or well, IDE in the editor. I have a small component. It's called a counter, and it extends from a component, React component. Inside the constructor, I can initialize a piece of state. As you can see, this state is local to this component, and the state is a very simple JavaScript object with just one property called counter and a default value. And I can define a function that lives over there, and the function is bound to this instance of the class. This is just a workaround because the this scope in JavaScript still doesn't work as you would expect from other languages. So it's just a bit of boilerplate. You need to do this, otherwise when you run this function, then this will be undefined. Now, this being undefined will never allow us to invoke the setState function on it, obviously. Now, my render method is also pretty simple. I have a div element. Inside the div element is a button with some kind of a text. And the button, this is just a very thin wrapper around the HTML button element, allows us to specify an onClick property. And the onClick property should be a function, and that function will be invoked at the click of the button. Now, what we can see is that it will invoke this.increment, and we saw here that this.increment has been bound to the correct this instance. So this function will run and will invoke this.setCounter. And if we would be running that, bless you. As we can see, we have a text over there. Let's increase it a little bit. It says clicks 0, and I have this button increment. And if we look at our source code, we can see our ECMAScript 6 code here. It's a nice feature of many tools around in the React environment that they have some kind of source mapping. So what we see here is the code that we wrote, not the code that's actually being run in the browser, but just the code that we wrote. We can put a breakpoint in there, we can click the button, and as soon as we click the button, the debugger pauses inside that method, and we can see around what's happening. So this button is just a thin wrapper around the HTML button, and as soon as I click the button, some kind of function is invoked. I'll allow the function to run. And as we can see, it sets a new state where it looks at the current state, increases the counter with 1, and then puts that back as a new state. And, well, it's not very high-end logic, but I can keep on clicking for a while if I would like to. So we can update the state of parent components from inside child components, but only because we give this child component a function, and that function somehow needs to live somewhere else. And in this case, it lives on the class. And that means that it can access the state of this class, this instance of the class, and update it. Now, if you're like me, and you see this at first, I was impressed. So, wow, it's magic. I can have JavaScript returning XML, and it updates immediately, and it just knows when to update things, and I don't have to care about that. There's no binding or whatsoever. But wait a second, how does this actually work? And to understand how this works, we need to go one step deeper, obviously, and look at how React does this internally. And the main concept that React uses is its notion of a virtual DOM. The virtual DOM is just what it says. It's a virtual document object model. It's not the real document object model. It's virtual. It lives somewhere inside the JavaScript runtime. And it's actually a copy of what the document object model of that page looks like. Not the whole document object model, but just the part that we used to mount our application to. Remember, when we have a React application, we do something like this, React DOM.render, and we supply it one document object model node. And React will have a copy of everything under this particular DOM node. We'll have a copy. And the virtual DOM is just a shadow copy, so as to say, where React will do its magic. So it will look at that, and it will look at the actual DOM, and it will try to keep those in sync. Now, the actual DOM is, at the end of the day, just a simple computation over the props and the state of your application, which returns into some updates of the virtual DOM, which turn into updates of the real DOM. And whenever your props or your state change, React will update its virtual DOM for the element that was concerned, and optionally also for its descendants, and it will recalculate that virtual DOM and decide what has changed in the virtual DOM. Now we have a difference, because there's this actual DOM that lives in the browser and that we can actually see, because the browser renders that for us. And there's this virtual DOM, and that has updated. Elements might have been added, elements might have been removed, attributes of elements might have been changed. And we need a way to reconcile the two. And React calls that reconciliation, very appropriate name there, and it's based on two major assumptions. The first assumption is that two elements of different types will always produce a different subtree for that element. And the second assumption is that you can hint, as a developer, which child's elements may be stable across re-renders. Let's look at that. How does this reconciliation actually work? Imagine we have two elements, one of them from the actual current DOM, the other one from the updated virtual DOM. How can we decide what to do? First of all, we can check whether these elements have different types. If they have different types, we just assume that the old subtree is not valid anymore, and we can tear it down completely and build a new tree from scratch. Now, if the two are both DOM elements, and they have the same type, then we can assume that only some attributes might have changed, and we can just update the DOM attributes. If, on the other hand, they are React components, we need to verify their type. If they are the same, then we will be reusing the same instance of the ECMAScript 6 class. Why is that? That is very simple. It's there so that we can maintain the state of that particular instance. And once we've done this, we can easily descend into child elements and repeat the whole process. Now, this might look like a very complicated approach, a lot of work, and we need to keep the two copies in sync. But the thing is, DOM manipulation in many browsers is still a very expensive operation. What React actually does is keeping this shadow copy, simply because object manipulation in JavaScript is much more faster than actual DOM manipulation. And doing all these calculations about React components being rendered and props changing and states changing can easily reflect to updated object structures in your JavaScript runtime. And what we try to do is minimize the amount of changes that need to be performed on the actual DOM. Something to note is when it comes to child elements of the same type. Imagine, for example, that our application has a list of locations where you can attend Devoxx. Very important list, of course. Well, it might look like this. There's Antwerp and there's London. And now another Devoxx comes up, for example, Devoxx France. So we need to add Paris to the list. Now, if you take into consideration the algorithm that we've just discussed, you might think, okay, there's new child elements, so we need to tear down the whole UL element and then re-render it, because child elements are also properties of the parent in React speak. Well, that's not a very efficient approach. And that is why React allows you to specify keys. And if you specify a key on a child element, for example, in this case, you specify a key on the li tag, you're saying to React, if we are re-evaluating the whole tree, as long as the key stays the same, the element is the same. And you don't have to tear it down and build it up again. So now if we add Paris, React can easily see that the first two elements are the same because their key is the same and will not tear them down and not build them up again. And basically it allows React to match the old subtree with the new subtree. So quite a big impact on performance that it can have. And the only thing that you as a developer should do is make sure that the key is some stable value. So as long as the element stays the same, the way that you calculate the key should also stay the same. And what you often see is that people just iterate over an array, for example. Each element in the array should be a new li tag. Well, what is easier than just using the index of that element inside the array as a key? It's stable, it doesn't change when I update the array, except when I add something halfway in between. But then again, I should indeed replace some elements. Now, we already saw that components have a render method, or they actually are a render method if we write them in a functional style. And if we write them in a class style, we add this special method called render. Actually, render is just one of many so-called component lifecycle methods. And these are divided into a few categories. The first category is while mounting. If we have a React component, the first thing that will be run by the JavaScript engine is the constructor of the class, obviously. Because if we do not have a constructor being run, we can't instantiate the class and we can't use the component. Second, React will invoke the component will mount method, if it's there. Most of these methods are not required. You can easily leave them out if you don't need them. But you can define them if you need them to hook on to this lifecycle. Component will mount, just as the name suggests, will be invoked just before the component will actually be mounted onto the page. During mount, the render method will be invoked, which allows your component to define what its view looks like. And after that, it will invoke the component didMount function. And component didMount obviously is just there to indicate I have just been mounted to the page. Now I might want to do some final things before sitting here and waiting for user input to happen. Now, if for some reason any of my parent elements updates, maybe my element will need to be updated as well. In that case, we first have this method that's called component will receive props, and it will be invoked just to indicate that the component will be receiving new properties. This one's particularly interesting. It's called should component update, and it's a way for your component to tell React, okay, thanks for these new properties, but that doesn't change anything for me. So you don't need to re-render this instance. You don't need to re-evaluate whether its subtree is still alive, because I'm not interested in this new properties. And the method will receive the new properties that are about to be used for rendering the component, and it should then return either true or false, saying, yes, I need to be updated, or no, I do not need to be updated. Then, just before your component will be updated, there's this hook method called component will update, indicating you are now about to be re-updated, to be re-rendered. Then the render method will be invoked again, but now with new props. And finally, to indicate that the update has finished, there's a component did update, indicating the update has now been done, all child elements have also been updated, and we're returning up the tree. If for some reason your component does not need to live on the page anymore, that's called an unmount. That basically says the component will be removed from the page. And there's just one method to indicate that, saying the component is about to be removed from the page. You can do some cleanup if you wish. You can maybe store your preferences to local storage, disconnect WebSockets, do whatever to prevent resource leakage, but prepare to be removed and disposed of. And then there's a few other component methods. Again, these aren't required, but you can add them to hook onto that particular event being there. For example, there's component did catch. Component did catch is a method that will be invoked, if it's there, whenever somewhere in the lifecycle of itself or its child components, a JavaScript error was thrown. It's there since React 16, which is, by the way, not yet included in React Native, just a beta of it, but will soon be updated probably. And it allows you to hook on to unexpected errors being thrown somewhere. There's also setState. We already saw that one. setState is a method that you actually inherit from the component class. setState is there to allow you to update your own state, and we'll look to that in a minute. And there's forceUpdate, which is actually the inverse of should_component_update. With should_component_update, I can indicate that I do not need to be updated. With forceUpdate, I can tell React I need to be updated. Maybe for some reason you did something that did not trigger a reconciliation. Well, using the forceUpdate, you can actually enforce that to happen. A few words on setState. setState, if you come from a Java background, you might be tempted to think that it will just set the state of the component. It does not. setState is actually a request to update the component state. And that request can come in, is passed as the first parameter to the setState function. And as a second parameter, you can optionally supply some kind of a callback that will be invoked after the state has been changed. Now, what does a state change look like? It can be two things. It can either be a partial state. That's the approach that we saw in the example with the counter. It's just a JavaScript object with some properties, and that will be merged with the existing state. That might be just overwriting if the shape of the two objects is the same. It might be merging if you add new properties. The other type of a state change is actually a function. And the function will have two parameters. The first parameter is the previous state, and the second parameter is the current props with which the component is being rendered, and you should return again a partial state. Now, this is really noteworthy to keep in mind if you start developing with React, because if you do not know this, you might be tempted to think that I just invoked setState and I updated my counter. Why was it not updated one line below? Well, because it's a request to update the state change. And what React actually does is that it allows itself to batch up a few of these state changes and then run them in one run, run them at once, and that's actually just a performance optimization, because that allows React to do just one reconciliation instead of a lot of reconciliations. So this is all for React. There's room for some questions right now about React itself and the way of working with React. Are there any questions at this moment? No hands. Great. Then it's time for a little break. Get yourself a coffee or some soda, and see you in 15 minutes. Welcome back. I hope you've enjoyed your coffee or other drink. And first of all, congratulations for surviving the boring part of the talk. We've not covered React at all. I mean React Native. We didn't cover React Native at all. And with a title, Building React Native Applications, you might be disappointed. I hope that the second half will not disappoint you at all, because what we've just learned so far about React is necessary to understand how React Native works. So, let's get back to this one-line summary from the React Native website. We have seen the design of React. We have seen how it works under the hood. We've seen what kind of thoughts lay behind its design. And now that we know all this, we can focus on building real native applications. Let's go. First of all, I want to take you along the internals of React Native. We'll see how a React Native application starts. Once it has been started, how it executes, and what its runtime looks like. So application startup. In a typical React Native application, you'll have your APK or .app file that you can ship in a Play Store or App Store of your choice. And this is just one big file, but inside this file are a couple of things. First of all, there are some native modules. Native modules is code being provided to you either by React Native itself or by any open source components that you might be using, or maybe you've written some yourself. There might be a JavaScript VM inside your application, and there's a JavaScript bundle. And a JavaScript bundle is just the combination of all JavaScript code that you've written and that you've been using in your application. As your application starts, your application will load all these three parts. When the native modules as well as the JavaScript VM have loaded and the JavaScript VM has been initialized, it's ready to load some default configurations, which is provided in a JSON format. And you typically don't need to touch it, but it's good to know that it's there. And once that has also been done, the JavaScript bundle will have been loaded as well, and your application is ready to run the JavaScript that you've either written or reused. And this JavaScript execution is actually nothing special. It's just as well you might be expecting when you come from a web background. JavaScript inside a React Native application is executed by JavaScript core. JavaScript core is the JavaScript runtime that comes with WebKit, and WebKit is the rendering engine that powers Safari. So that means on an iOS device, you can be sure that there's always Safari installed, and always WebKit will be installed, and so JavaScript core will be there. On Android, you can't be sure of this. And that's why in an Android application file, there will be a JavaScript core implementation packaged along. Now, your application will be running inside JavaScript core, except when you're debugging. You can debug your application, even when it's running on a on a physical device, so not on an emulator, but on a physical device. You can debug it using Chrome. Chrome will attach to the JavaScript process. No, it's the other way around. Your app will be running on your computer at that moment. So the JavaScript runtime is in Chrome, so it means it's V8, not JavaScript core. And the JavaScript engine inside your computer will then talk to the native modules that live inside your phone to do all the things that need to be done on the device. And the process for that is really straightforward. It's just like any other JavaScript runtime. It starts with parsing this package JavaScript, which is called the bundle. If it has been parsed, it can generate the abstract syntax tree for that. The abstract syntax tree can then be translated into bytecode, and the bytecode will be run on the device. There's nothing really special there. But then you might be wondering, where's the native part of all this? Because it's called React Native, so it has to do something with being native, right? Well, that's what this picture tries to explain. Your program, as I said, starts with executing a bunch of JavaScript. This JavaScript will do a few things. It will create shadow views of all the user interface elements inside your application. This is what we just saw in the React web environment. It's the shadow DOM. Well, here's not a shadow DOM because a mobile application doesn't have a document object model. But it has a shadow copy of all the views inside your application. These will then be laid out according to the constraints that you give it. And the JavaScript execution will also instantiate the real native views. These are the native UI elements from either Android or iOS, and that's what makes sure that a React Native application always not only looks native, but also feels native. It feels native because it is native. It just uses the same UI elements that are in each and every other mobile application for that platform. If the layout has been constructed and the native views are being built up, your application is ready to put them on the screen, which is just called rendering, of course. And that means the end user can see them. Now, if you interact with your application, for example, you tap on a button or you swipe left or whatever you do, you try to stop the application. There's kind of an interaction between you and your application. That interaction is being handled by the UI kit. The UI kit is just a tiny bridge into some native modules that do the actual event handling, and that will, in the end, invoke the callback handlers that you have written in your JavaScript. Your JavaScript execution also starts some bridge module that actually provides the bridge between the JavaScript world living over here and either the iOS or the Android world living over there, which is the native modules. React Native consists of a bunch of JavaScript files, which is the API that you program against, and also a lot of native code, either Java or Objective-C, which provides all kind of implementation details for that specific platform. And when you run React Native in it, as we saw at the very beginning, you can also get a few of these files generated for you, because you can't run an application without having at least some kind of starting point. Let's take a quick look at that. That's over here. As you can see, there's a folder structure created for us. There's an Android folder. Inside the Android folder is an app folder. Inside the app folder lives a source directory, which in the end contains some Java files. For example, this is just an activity. If you're used to Android programming, you know that everything in Android is an activity, and it just extends some kind of React activity that comes from a shared jar file. And there's an application that comes along with some generated defaults. And of course, there's a manifest file as well. And the manifest file is packaged together with the application to describe what the application looks like, which icons there are, and what the main activity is. More or less the same holds for iOS, except that it is better to watch in Xcode. As you can see, it generates a standard Xcode project for you with some Objective-C files like these. We don't go through these because they're not particularly interesting, but that's actually where the starting point for your application. And it tries to do nothing more than bootstrap the JavaScript environment, load the bundle, and then have the JavaScript to do whatever it needs to do. Now that we know what the basic structure is of a React Native application, it's just a JavaScript runtime which tries to interact using native modules with the UI elements of the platform. A lot of new questions can come to mind. Like, how can I make sure that my app looks okay? How can I invoke REST APIs? How can I store data? How can I test my application, package it? What do I do with state and data inside my application? And we'll dive into each of these in the following time. First of all, when it comes to styling, this is a JavaScript environment, but it's not a browser. And that means that there's no thing such as CSS. So if you think, oh, well, it's just JavaScript, I know CSS as well, so let's get going, that's not how it works. That's not how you can style your application. But all components that come with React Native do accept a style property. And as we saw, each property in React Native is a rich structure, potentially, not just text. We can supply objects to this style property to tell the component what it should look like. Now, what is such a style that we can pass along? React Native comes with an API that's called the Stylesheet API. You invoke its create method and supply it with a JavaScript object structure. Here I have a very simple example. I define just one style, which is called red. And the red style, maybe it's not a good name because it's also the name of the color that we're using. The red style says that everything that's styled using this style should have a red color. We could also have picked the RGB notation or a hexadecimal notation, but my personal preference is just to use names because that reads a lot easier. And now if we have this hello component again, then we can see that we just supply the red style to that component. Let's see. Well, my apps are still there. This one's also still there. What if we would say, for example, this instruction style, it's all nice, but I don't like this color. I want it to be red. Well, as you can see, it reflects immediately because live reloading is still on. And the instructions style that was there, used there, has now this new text color, which is red. I think it's something like font style, but I'm not completely sure about that one. Nope. Empty. Not what I was expecting. Well, let's remove it again. Still empty. That's better. What you did not see in the meantime was that, well, I can show that by the way. If I do something that's not understood, font style, for example, bold. Now what we see here is the default error screen of React Native. And what it says, you've been using a font style prop, and it has the value bold, but I didn't quite expect that. Now, there's a decomposition of what style I used effectively, and there's a stack trace which is somewhere deep inside React Native itself, so that doesn't really help us. But at least we can see that we did something wrong with the styles, and that we should fix that. And apparently there's no thing as a bold style. It should be either normal or italic. Now, okay, we can change that to italic. And apparently after an error, the hot reloading is broken somehow. And we should manually reload it. Like so. Well, we can also define new styles. We could, for example, give it a Devoxx style. Background color should be yellow. Not sure if that's compliant with the official look and feel of Devoxx, but what gives. And we could, for example, change that part of the user interface, and now it gets a yellow background. There's a lot more style properties that you can use. Each component that is inside React Native has its own documentation of what styles it accepts and what the effect of them are. It's not only about the colors and the size of your fonts, it's also about rendering, laying out your component. Should it span the whole screen? Should it be just 50%? How should it align to other components? So there's a lot of things you can play around with. But the thing to keep in mind is that this is not CSS. That's very important. One of the consequences is that you need to use different names. For example, it's not font-size, it's font capital S size. And there's a lot of more of these because there's no dash, obviously, when you want to write a JavaScript property. It also means that you do not have inheritance like you would have in CSS. If you would have elements nested inside each other, they inherit their parents' style, and that's not the case with React Native styling. You can do a little trick, which kind of circumvents this. It's not very elegant, but it does work. What we see here is that we have a small object which is called the screen, and I'm saying that it should have a red color, it should have a bold font weight, and it should be size 30. And now I want to create a new style which actually inherits all the other things. Now I'm doing that by starting with the triple point screen, which is a very new JavaScript construct called object decomposition. What it says is I'm decomposing the screen into each of its individual properties, color, font weight, font size, and supplying those as new properties to this smaller variable. And then finally I'm overwriting the font size to be 20 instead of 30. And the result will be a new object with properties color, red, font weight, bold, and font size 20 instead of 30. And now I could use the style sheet create method. And there's another neat ECMAScript 6 construct which is called object decomposition. And it says if you have a variable in scope that's called screen, you don't have to write screen colon screen, saying there's a screen property in this new object and its value equals the screen variable that's currently in scope. That's a bit verbose. Instead, we can just say, I'm creating a new object. It has two properties. One of them is screen, and its value equals the variable screen that's currently in scope. And its other property is called smaller, and the value for that is the variable smaller that lives in my scope. So that's all there is to it. You do have some ways to style your application, to lay out components in a way that they interact with each other. But you do have to keep in mind that the rules that you might know from CSS do not apply in this world. Second question is about working with REST APIs. And here it's really very important to remember that in the end of the day, we're just writing JavaScript code. And if you're using JavaScript, it's pretty easy to invoke REST APIs. Of course, we've been using jQuery and friends for decades, and that worked quite well. But in newer browsers, we also have the fetch API. And the fetch API is a proposed standard that is, as far as I know, implemented by almost all browsers. The fetch API defines a method called fetch that lives on window object, so it's always in scope. And the fetch method, as we can see inside this little code snippet, first accepts an address that should be invoked. And secondly, I can pass an object with some options for that request. For example, I can say that I want to have a GET request, which is, by the way, the default, so it's a bit obsolete here, but just for illustration. But I can also specify custom headers that should go with my request. And in this case, I'm, for example, telling that I want 2 extra headers, one of them being an accept header and the other one being an authorization header with some kind of an access token. As we can see in this line, as well as in this line, there's another special construct, which is called string interpolation. It's indicated by not using single quotes or double quotes, but using backticks. And as soon as you write a string that's surrounded with backticks, you can easily interpret variables using the $accolade signs. So here I'm referring to some variable that is not displayed, but lives somewhere, telling me where my backend API lives. Here I'm referring to a local variable that came in as a method parameter over there. And I'm just putting that together with the text bearer space to construct a new string bearer space, yada, 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 some kind of a token. Now, if I invoke this fetch method, I do not get a response. Instead, I get a promise. Promises are also part of newer JavaScript versions, and they're a bit like asynchronous programming in other languages like Java or C#, maybe also as well. A promise is, well, just what it says. It's a promise to deliver a value at some moment in the future. We don't know exactly when the promise will be resolved, but it will be resolved. That's part of the deal. Now, if the promise is resolved, we can tell the promise API, I want to have a callback method invoked as soon as the promise is resolved. And you do that by invoking the then method on the promise value. Well, in this case, we're referring to another method that lives just a few lines above. It's called the process response method. It gets the response. It tries to read the response data and parse it as JSON. Now, the thing is that this also is a method that returns a promise. So we have a promise that returns a promise. And once the second promise is resolved, we can check whether the response was actually okay. If so, we can return the parsed JSON just as a JavaScript object, or otherwise we can return a new promise, which is rejected immediately. As with promises between humans, promises in computer science can also be broken. And in JavaScript world, it's called promise rejection. And it just says, well, I promised to give you the response of this JSON this REST API, but I'm not going to do that. Maybe the access token has expired. Maybe the API is down. We have a network issue. It could be all kinds of things, but somehow I was not able to keep my promise. I'm sorry to disappoint you. Here's a rejection. And in that case, it will eventually become, when you transpile your code using Babel, an error that will be thrown, and your application needs to deal with that. Now, finally, to complete this tiny JavaScript file, we just export the retrieve products method. And from our React component, we could just say import retrieve products from, well, wherever this code appears to live. And it will give us a method that, when invoked, returns a promise. And when the promise is resolved using this data variable, we can, for example, update the state of that component so that it will reflect the data that we have just retrieved from our API. And that's all. If you would be writing a JavaScript application using React for the browser, it would look, I think, 99% the same. There's nothing special. This is nothing React specific, React Native specific here. In fact, it lets you reuse the knowledge that you already have from your web applications. And you might even be able to write some common JavaScript modules that you can just upload to NPM or something, so that your web application and your React Native application use part of the same JavaScript code base. Second thing would be storing data on the device. That's an interesting thing, because as we saw, React Native allows you to write code that runs on two platforms, two platforms that are very not similar. They do not share a lot in common. So what React Native does here, it provides you with an API that abstracts away all the platform-specific details. And this API is called the Async Storage API. The Async Storage API is just another JavaScript API that comes with React Native, and it allows you to store and retrieve any kind of data that you would want to store in your application. If your app runs on Android, it looks to see if RocksDB is available. If it is, it will use that one. Otherwise, it will use SQLite. If your app is running on iOS, it will look at the size of the data that you try to store. If it's small, it will put it in a dictionary. If it's large, it will put it in a distinct file somewhere on the device. But for you as a programmer, it doesn't matter. You don't have to know, you don't have to care about this, because the Async Storage API abstracts away all of these implementation details for you. What does it look like? Well, writing some data to retrieve it later is just a matter of invoking the setItem method on the Async Storage API. You need to supply two things. You need to supply some kind of a name or key so that you can look it up later. And you need to supply some value. My app wants to store the username that the user has chosen to log into the system. And apparently, this is just Manneke-Pis. It's not from Antwerp, it's from Belgium, from Brussels, but that doesn't matter. And again, the name actually already is kind of a giveaway. It's asynchronous. So this method also returns a promise. Now, sometimes you don't want to return a promise as well. Sometimes you just want to wait for the promise to be resolved or rejected. And you can do that in ECMAScript 6 with the new await keyword that we see here. If we would say await, followed by some kind of JavaScript construct that gives us a promise, Babel will generate a lot more JavaScript than that we see here, which does a lot of magic, which basically boils down to, okay, we have this promise, we keep on waiting until it is either resolved or rejected. And if it is rejected, well, we might not be able to conclude in a normal way, so an error will be thrown, and we can do some kind of error handling. We can maybe show a big red screen or just some notification message. Loading data is pretty similar. You just invoke the getItem method. The getItem method needs just one parameter, the name of the value that you want to retrieve. Again, this is an asynchronous API, so we can use the await keyword. This time we are actually interested in the result of the method. So we can say my username equals the value of awaiting a promise delivered to us by the Async Storage API. And just in case there was no item stored before, we will get back a null value, so we can either return the username itself if it wasn't null, or an empty string if it was null. And again, since this is using the await keyword, we need to catch an error that might be thrown when the promise is rejected. Next thing would be testing your application. We already saw that applications are composed of small building blocks, components, and these components can be expressed as just functions of the properties that they received and the state that they've built up themselves. And then the question arises, how can I test such a component? Well, first, a very naive approach would be something like this. I have my component, it returns a div element, so I can use JSX. It allows me to inject XML values as if they were JavaScript variables. So I can just invoke my method, give some props, and expect the outcome of that method invocation to be some other XML literal value. What could possibly go wrong? Well, one thing that could go wrong is that you get a test failure, and one that's not really easy to understand. It says expected value to equal something else, but the expected value and the received value are pretty much the same, as far as we can tell from this error message. That's strange. Why doesn't that work? Any clues? Spaces? I hear someone say spaces. The text was split into two DOM elements. That's true, and that might be the reason. Any other thoughts? No other hands? Oh. One is red, the other is green. No, that's just how it's being printed to the console. Now, the reason why this doesn't work is that the render method, as we saw, returns a JSX element, but a JSX element is not something that's natively supported by any JavaScript runtime environment. So what Babel does for us is it translates it into an invocation that looks like this: return react.createElement. And if we invoke this function twice, we get two React elements that do have the same type, but they're separate values. They simply aren't the same. So we need something better for testing. We can't just invoke the method and hope that the XML values will match. Wouldn't it actually be cool if we could render our components inside some kind of runtime environment and then invoke any expectations on the rendered component? Well, turns out you can do that. React comes with the React test utilities. And Airbnb, one of the companies that uses React Native a lot, also have written their own extensions to that, which they've called Enzyme. I don't know why they chose that name, but that's what they chose. And let's look at two methods for testing your React component. The first one is called shallow rendering. And shallow rendering is an approach that you would use if you want to test just your component and not do any verifications or expectations about the child components that live under it. So if we remember the hello message component that we've seen earlier, we could write a simple test case that says it should render some kind of expected text. We would invoke the shallow method from Enzyme, pass it the React element using the props that are needed for our test case, and we get back some kind of wrapper object, and the wrapper object has all kinds of methods that we can use to inspect it. For example, it provides a text method that we see here, and that will return all the text elements that live under it, but only at the very first level. So if there's any nested elements, we don't see those. We see just the text of the immediate children of my hello message component. And we can verify that the text indeed equals hello Devoxx. If, for example, I would have a very different component, for example, I have a shopping application and it has a component that, that I can use to show all the products that my shop has to offer, I could shallow render the list of items component. I would pass it a simple array of components, say X, Y, and Z. And I could use another of the wrapper methods to inspect what the component has done. And in this case, we're looking for any child elements of type item, and we expect that there will be 3 of them. We could also check that each of them is passed one of these items from my source array, but we cannot use shadow rendering to verify that they did indeed render the product correctly. We can also verify that they are there and they have some props, and that's about it. We can't do anything deeper than that. If we want to dive deeper and want to verify that the child components are also working properly, we need full rendering. And full rendering is something that tries to render the whole tree and subtree of your component. But that means you need something like a document object model to run it in. You could use JS-DOM for that, or you could use a real browser for that, it doesn't matter. But you need either of those. And if you would do that, you would use the mount method from Enzyme. For example, you could use some other testing library that you prefer to create a stub function. And then you could say, okay, if my hello message is being mounted to the page, it somehow invokes this method. And, well, that is possible because the hello message is really mounted to a page when we use full rendering. It's not shallow rendering, which basically invokes the function. No, it really tears up a document object model. It attempts to run React, mount the component that you gave it, and see what manipulations that does to the underlying document object model. And that means that it also runs all of the lifecycle methods that we have seen before the break. And we can verify that these have certain effects. For example, invoking an API to retrieve data, or storing user preferences somewhere. Which brings us to the question, okay, but there's also event handling. How would we test that? Well, again, Enzyme helps us with that. We don't need full rendering for that. We can do that with shallow rendering. Again, we need to create some kind of a mock or stub that we can do our expectations on. We would mount our custom button. We have somehow requirements that cannot be met by the standard button component, so we have our own button, because if we didn't invent it ourselves, it's probably not good, so we invent ourselves a new button. We supply it an action. Now what we can do is we can ask the wrapper to find a child element inside my awesome button, and we can simulate an event happening on that specific child. In this case, it's the click event, and when that fires, we can then verify that the dummy has indeed been invoked. Now, since this is all asynchronous, event handling is per default asynchronous process, you might need to actually write your test a little bit different by saying set a timeout. Inside the timeout, I will be verifying that my stub has indeed been invoked, and I will give the timeout a default of, for example, 500 milliseconds. And my test case has only succeeded if the timeout was invoked and it was running correctly. Okay, so we've built our application. We've made sure it looks nice on both devices, both platforms. We've tested it using unit tests. We know it's good. We want to upload it to the App Store and the Play Store. How do we do that? With React Native comes a bundler, and they've recently pulled the bundler out of React Native and gave it its own name. They've called it the Metro Bundler. It's a JavaScript bundling tool specifically meant for React Native. And what it does, it looks at your JavaScript files that you've written yourself. It looks at all the JavaScript code that you reuse from other libraries that you might be downloading over NPM or whatsoever. And it bundles all of these into one big file. the .bundle file. Now, depending on what you are currently doing, it will do one of two things. If you're developing your application right now, it will just serve that file over HTTP. As we saw, we can even enable hot reloading so that the server will push a rebundled file over the network. But if we are preparing for production, we do not want to be dependent on some kind of packaging process that lives here on my MacBook, obviously. So in that case, the bundler will do something different. It will write the bundle file to disk. And the bundle file can then be included with the application to be packaged together. Now, if you want to make a production build, the processes are slightly different for either platform. On Android, you need to create a signing key first. Apps that are to be deployed in the App Store, the Play Store, need to be signed. You can generate a key yourself using the standard key tool that comes with Java. Then you would update your Gradle file to point at the correct keys and supply it the password for the key and where it can find it. Then you need to build the release APK file using Gradle again, using the assemble release target, and you would probably fetch some coffee at that moment because it takes quite a while. It will compile the Java code, which is not really a lot. It will do the whole bundling process. It will do dexing. It will do minification. You can hook ProGuard into that. There's quite a lot of stuff going around before that process has finished. And once you're done, you have your APK file. For iOS, it's a little bit different. First, you need to have an Apple developer account. That means you pay Apple, I think, $100 a year to be able to publish applications other than on your own phone. You need Xcode. You need to tell Xcode that you have this Apple developer account and that you want to sign your code. Then, optional but highly recommended, enable app transport security inside your iOS application. App transport security is off by default on React Native. It's a tiny switch that tells your application to only load resources over trusted connections. During development, your packager is running on your Mac or on your Windows machine. It doesn't really matter. And it's running over plain HTTP, so not HTTPS. And that's okay for development purposes. But on production builds, well, we're not depending on the packager anymore. And if we are invoking remote APIs, there are probably APIs that allow us to purchase stuff or to retrieve user information or whatsoever. And it's a good practice to have that over HTTPS by default. So that's why you need to switch on app transport security. Then you need to build your application. There's a shortcut for that in Xcode. I think it's Apple B. And again, you can grab a coffee at that moment because it takes quite some time. So before you go to production, you will have at least 2 coffees. Now, looking inside the APK file, APK is basically just a zip file, so you can just look at it using unzip. As you can see, my app was built for the ARM platform v7, and it's a release APK, meaning that it has been signed, it has been dexed, it has been compressed using ProGuard. Inside the APK file, we will find an assets folder. The assets folder contains fonts and stuff, but the most important thing is it contains an index.android.bundle file, which is the whole minified JavaScript bundle that is optimized for running in production. It also contains res folder, where the layouts live, and some images if we package them along. There's a classes.dex file, which is just standard Android stuff again. And there's a lib folder, and that contains all the shared libraries, native code for the Android platform. Now, for iOS, we will get a .app folder, and if we look inside that, there's app icon.png. There's just a bunch of PNG files that are just the icons for my app in various formats. There's a big file with the name of the application. It's a binary file, which is actually one binary for two different architectures. In this case, when I built it on my Mac, it gave a binary for both ARM7 and ARM64. And again, there's a big file which is called main.js bundle. I don't know why it has a different name than on Android, but it has a different name. And again, it's the minified JavaScript bundle. Let's see if we can find that one back. It's a big bundle file. It's around 500 kilobytes, as we can see here. We could look into that, and we'll probably see that it has been minified. It's not really easy to read anymore, but that's not important. We're shipping this for our end users. And there's just one thing that we are concerned of, and that's runtime performance. We don't need stack traces anymore, because if things go wrong, we're not there sitting next to them so we can look at their screen. We can't debug it anymore because it has been distributed over the Play Store. We don't know where it runs. The only thing we care for is that it's really fast. So everything that's not of particular interest is just minified to names like N, E, R, I, O, A, F, and S, for example. We have no clue what it does, but it doesn't matter because the packager took care for us. Next topic, managing state and data in our application. Let's think again of the example where we are building a shopping application. And our shopping application is probably something like this. Of course, we have our root element at the top. When we start the application, we have some kind of a loading indicator that waits while some data is being retrieved over the network. And then we have a list view that shows us the most favorite products or the best buys for this moment, using some list view showing separate items. And if you click on an item, you can get a detailed view. Now, the thing is, if we're building an app like this, we know we are encouraged to encapsulate state at the place where it should live just for that component. But there is some state that is global. Things like usernames, for example, or access tokens, if we use OAuth or something like that. And where would we need to store that? We could say, okay, well, the app is just responsible for getting all global variables. But that doesn't solve the question, because if we determine those values in the root component, we're not going to pass them down through the whole component tree back to, for example, a detail item view that retrieves some extra information using the API. But that would mean that our loading screen and the list view and the item view, they all need this access token or this username. They don't do anything with it. They just pass it down to their child components. That violates the separations of concerns. That makes our components less reusable. That's really not a good approach. So what else could we do? One of the solutions that you could employ to tackle this problem is Redux. And just to make sure, Redux is not tied to React Native. You could use Redux in web applications in your browser. You could use Redux even for command line applications that you run using Node.js. And you can use it also in React Native applications. Now, Redux is centered around three main principles. The first principle is that state, application state, is a single source of truth. So there's just one state, and it is not copied. Just one value. The second principle is that state is a read-only thing. So once I have established my application state, it's not mutated anymore. That's interesting, because if my state is read-only and I'm not mutating it, then how do I update my state? Isn't that like a global constant or something? That's not useful. You can change the state of your application in Redux by emitting an action. And actions are just regular JavaScript objects with just one requirement: they should have a type property. And the type is a name that you can think of yourself. Changes to your state are made using pure functions. These pure functions are called reducers. And reducers take the current state, this one source of truth. They take the current action that has just been emitted, including any parameters that might be inside the action, and they return new objects. That's part of reducers being pure functions, is that they cannot mutate existing values. If they would get the current state and just mutate it, it wouldn't be a pure function anymore, because pure functions are not allowed to change their parameters or any state that they do not own themselves. So what a pure function does in this case, a reducer, is it returns a new object, which is just the new state. And Redux will then replace the current state with this new state that your reducer has returned. A nice thing, of course, is that pure functions are, if you write them correctly, easy to test. So that makes this a very interesting strategy. Now let's look at how that works. I have a simple HTML application here, which uses Redux. Let's look at the source code for it. What we see here is that we first define the initial state. The initial state is just a JavaScript object with one property. The property is called to-dos, and it's an empty array. I don't need you at this moment. Next, we define a reducer. The reducer is a function, and it has two parameters. One of them is the state, and the other one is the action that's currently being emitted. Now, if the state would be undefined, we use another ECMAScript 6 construct here, where we say then its default value will be initial state. And this is just a very easy way to ensure that we always have a valid state. So we don't need to think about state being undefined initially or something. That's being taken care of. And our reducer simply looks at the type attribute of the action, because that's the only thing that's actually required in Redux. And it will return, if nothing else is the case, it will always return the current state. Next, we ask Redux to create a new store. The store is where this state lives. And we tell it, here is the reducer that you could use to process emitted actions. And the first thing that we could do is we could say, okay, dispatch an action of type add to do. Now I can use additional parameters if I want. And in this case, I'm having an additional parameter that says the title of my to-do item is speak at Devoxx. Has been a long-standing wish to do that, so, well, could be there. And now what we do is we just use some ugly document object model manipulation, and we look for an element inside the DOM, and we just ask the store for the current state, make JSON from that, and put that inside the element that we just retrieved. And as we can see here, it says, okay, the Redux store is just a JavaScript structure as we expected with the to-dos property and an empty array. But did we expect that? I'm just saying as we expected, but did we expect that? I was hoping for someone to say, no, I did not expect that. Because we did dispatch an action here. This action is supposed to mutate the global state of our application. Why didn't it do that? And the answer is because there's a blank line over here. My reducer will get the initial state, being this tiny object. It will get an action with type add to do, but it doesn't know how to handle such a case. So we could implement that. We could say, in case the action is of type add to do. Well, one thing that we know is we should return a new state. We should return a new object rather than mutating the existing one. We also know that it is most likely a good idea to have a to-dos property in it. And then the question might be what to put inside there. Well, we could create a new array out of the existing one using array decomposition. It works pretty much the same as object decomposition. In fact, the syntax is the same. Station? Why did I type station? I want to look at the to-dos property of my current state, and I want to add something new to that. Well, let's look at this. Well, at least our array isn't empty anymore. There's an object inside it. In fact, it's this object. I could give it a title. For example, I could say, well, just get the title from the action. And now it says, I have one to-do item in my list, and the title is Speak at Devoxx. Well, since we have a to-do list, we need to keep track of whether we completed it or not. We could say it's not completed yet. And we probably need something like an ID. Okay, so here it is, my upgraded to-do list. It now has one item on the list. It says ID is 1. What I need to do, I need to speak at Devoxx, and it has not yet been completed. So we have a very simple reducer which always returns new objects rather than mutating existing ones. It doesn't even mutate the array inside the state. It just decomposes it into separate objects and then constructs a new object out of that. So that's already quite okay. And we could add support for more actions. We could say, for example, if there's a complete to-do action as well. Okay, we need to return a new value. Now we can look at the state again. Make a copy of the array with to-do items. Again, we're making a copy of that first. We're not mutating the existing array. We could also do new to-dos is state dot to-dos. Now we need to find the to-do that we're interested in, so we could say new to-dos find we're looking for one specific to-do item on the list, and when we have found that, we can mark it as completed. We're now allowed to mutate a variable because we first created a copy of it. Then we can change it. We could then complete the to-dos, passing it a parameter using ID1. Now if all went well, all did not go well. An action to-dos. Ah, got it. Thank you. And now it has been completed. I'm not leaving, don't worry. But that's how you can mutate your state by emitting an action, having a reducer that processes the current state and the action that you have just emitted, returning a new state for your application, and then using that to have your new global state. Well, this is all nice, but how does that translate to applications like we already saw React applications? Well, turns out that there's another open source library that we could use here, and it's called React Redux. And it provides a very elegant bridge between Redux with its one source of truth, its global state, and React components that want to access it. And the thing is that you need a provider, that's what they've called it. The provider is some kind of a Redux, some kind of React component. You tell it what your store is, and then inside the provider you boot your app just the way that you used to do it before. For example, inside my to-do application, I might have a very small component that just tells me how many things I need to do. And it might look like this. It's just a simple component that says there's a text component from React Native. There are yada yada tasks to do, with the count coming from the props. Now what we need to do, we need to supply two functions if we want to use React Redux. We need a function called map state to props, where we can map the current state of the Redux store to properties for some specific component. In this case, for our counter component. And well, this mapping is pretty straightforward because our component expects a count prop, and the value for that is very simple. It's the number of items in the to-dos array. The second mapping function that we need, the second helper, is map dispatch to props. And in this case, it's empty. Dispatch, remember, is the function that we use to emit a new action into Redux. And we could use this to process user input. So if, for example, the user clicks on a button, we could dispatch an action into Redux. Redux would run the appropriate reducer for that, and finally mutate the state of my application. And now what we could export is a new component returned by invoking the connect method from React Redux. We first need to supply the two mapping functions, the functions that map the current Redux state to the properties for this component, then the function that maps Redux dispatch method to other properties in my application, and then pass the components that we want to wrap. Note that in this case I've also exported the counter itself. That is not required. You could easily skip that. But the thing is that this way you have a mechanism to just test your counter itself without having to tear up a complete Redux store and reducers and stuff, and just verify that it correctly behaves using the properties that you specify. And for use inside your application, you would then use the default export to mount that in some parent component. And you could actually even export those mapping functions as well and verify that they also return the expected properties. So let's look at a somewhat bigger example. It's still in the to-dos area. The reducer is the same, but now instead of having just a dump of the Redux store, we try to glue together React elements with the Redux store. let's see. This is just as we saw it on the slides already. And we need to tell the provider where the store lives. The store is just the variable that we have defined above. Let's see what is the name of the, there it is, just index. Get element by ID. So we ask again, just as we saw earlier, for some kind of document object model node specified as the one that has ID root, and we try to mount the provider onto that. Get rid of that. Oh, it's already completed. That's an easy task. If we would not do that, we would see, oh, well, there's a list, says speak at Devoxx, and if I click it, it gets completed. How did that work? Well, therefore we need to dive into the list. Our application has a to-do list inside. The to-do list follows the pattern that we just saw. We have the React element itself. It receives some props. As you can see, the props have items, being just the array with all the tasks that we need to complete. So we can map every item inside that array using a function, and the function takes the item and returns a new JSX value. In this case, it's an li. Note also that here we have the key property, and we just take the ID from the task that we are currently rendering. It's stable across re-renders. It's unique, so that's okay. Now, if the item is completed, we determine some new CSS class. We return a new CSS class to be used so that it will be strike through. And otherwise, it will not have an additional CSS class. And the interesting part is here, because we have an onClick method, an onClick prop, sorry. And the onClick prop invokes one of the attributes of my properties. Which one? The complete. The complete to-do function here will invoke this function, taking the ID as a parameter, and then invoking the dispatch method from React, from Redux, excuse me. Well, then it obviously needs to say which action it wants to emit. It wants to emit the complete to-do action, and the ID of the task that needs to be completed is passed on as a parameter. So if we look at that, if we click on the item, we can see that the debugger pauses inside this object here, this object that has been returned from the map dispatch to props mapper function. And the ID that we got as a parameter is indeed ID number 1. And if we would step over this function, we would thereby emit a new action into Redux. The action would be of type complete to do. Redux would run the reducer. The reducer would replace the existing global state with a new global state. And our React Redux provider would then determine that this map state to props function returns some new properties. So this to-do list is re-rendered, invoking the class name method again, this time telling our application that this task was completed. And indeed, it gets strike through. there's also another tiny React component over here. It's called the new item entry. This time we're following the class style notation. Why is that? That's because we do have some state for this component. This component is there so that we can add new items to the list. And that means that we have a form. And when the form is submitted, we want to invoke the add_to_do method. Well, the add_to_do method will just invoke the add_to_do prop using a variable that it kept in its own internal state. Even in a Redux world, components can have their own internal state, for example, in this case. And then we reset the state to be a blank new title. And we prevent the browser from doing an actual form submit, thereby reloading the page and getting rid of everything we've done so far. As we see here, the add_to_do prop is actually a function, and that function will again invoke React. Will again invoke Redux with a new action. It's an add_to_do action. It's not completed, and the title is just a parameter. Now we have the input element over here. It's a text element, nothing special. As soon as you start to type, we invoke the update title method. The update title method will just look at the value of the input element and use that to update our internal state. And then again prevent further event processing by the browser. And the value of the input element is just what we kept in the state. So what we're basically doing here is we're having our own tiny little two-way binding here just for this component. It's not on by default, but just where we need it, we need to write it ourselves. There are helper libraries that do this for you. And if you are looking to start a new holy war, well, maybe emerge in the question whether that's a good idea or not. I've seen very heavy debates on that. For now, I myself prefer to just do it this way. And if we look here, make it a little bit bigger. Well, where else could one speak? Java Zone, never been there. So I could say speak at Java Zone, press enter, and then immediately the same process happens again. An action is emitted. Redux runs the reducer returns a new state. Global state is replaced. My components are re-rendered, and a new item is added inside the real document object model. There's still a breakpoint over there. Now this is a demo inside the browser just because it's a tiny bit quicker to see what happens and it's easier to debug. But all of this can also be used inside a React Native application. Like so. And if we wish to do that, let's see if we can have everything on one screen. It's a bit challenging, I'm afraid. But maybe we'll manage. First, we need to look inside our package.json. Package.json is like the POM of your application if you're used to Java world and use Maven. What we see is that we have dependencies and dev dependencies. And dependencies are the things that are packaged with your application and that end up inside the app or the APK. So we could add Redux and React Redux there. We would need to run npm install. I hope that goes okay. I'm not on the conference Wi-Fi, so maybe we're lucky today. Well, pretty quick actually. So now instead of this app that we have here, we could do something different. What we need to do is we will export provider. Store is provider. Notice that this is exactly the same thing as we did in the browser. The API is identical. We can have an app component as a function of properties to some text view. Well, let's just call it counter then, because that's what it does. It's not the best approach, by the way. Map state to props. It's a function that takes state and returns a new object. I'm expecting a count prop, so need to do that. State dot todos dot length. Again, const map dispatch to props. Well, this component doesn't do any user input handling, so we can just return an empty object. Map state to props. Map dispatch to props. Counter. That's not a good idea to call it counter again. Let's call it connected counter, because then we all know what it means. It's connected to something. Now, this is interesting. Will it work? We have a default import from the app.js, which has a default export for the provider with a store and a connected component that has the map state to the props and map dispatch to props connected to a component that doesn't know anything about Redux. Let's see what it does. Tries to load the bundle. Take it that the packager is still running. Should be there. If you show the modules there, try restarting the packager. Fair enough. We could do that. Oh. Now all of a sudden the other phone also picks it up. I'll restart the packager in the hope that that fixes it. It's on this screen, so you can't see that. Reload it, see what happens now. Oh yes, I forgot to import that one. Well, the other one will obviously also miss it. Can't find provider. That's always the issue if you start live coding. Store is not provider, store is store. And now since we've had an error before, reload isn't working correctly. Well, I could reload it, but there's no use in that, obviously. Expected a string, but got an object somewhere. There. Sometimes you need to do this. I'm not really sure whether this will make a difference. Still not okay there. It should be store. Still not good. It could be a moment to show how debugging works. That's the benefit of doing live coding. If it doesn't work, you can show how good the debugging support is. As I said, debugging is done over Chrome. So what we get is a very simple page in Chrome. No, wrong button. You could inspect the page, look at the source code that has been loaded. It's over there. And you could, for example, look inside your JavaScript file and see here that it has a default export. Okay. Let's first put a breakpoint over there. See what it does. I'm pressing reload over there. Okay. Now, the app is now running in Android. Let's see, it's there. You can see that it didn't have any screen yet. It's just blank because JavaScript execution is on hold in the debugger here in Chrome. And I could step over it. I could, for example, inspect the store, see that it looks okay. It has a dispatch function. It has a getState function. That's what I would expect from Redux. So I'm stepping over that. It has some style sheets that I'm not using anymore. And now it goes back to React, and it still gives the same error message. An interesting one. Didn't expect that to come up, obviously. Let's see. We have the text imported for the counter. We have map state to props. We have map dispatch to props. We're mapping the state to some new properties over there. Should be connected counter. The question is, in this index.js file, we're importing an app from a file named app in the same folder as we currently live in. That's this app.js, but you don't export an app over here. And the answer is no, that's correct. We do not export something that's named app. But in this syntax, import name from string, you're using the default export from that file. And the default export is not named, so we need to determine a name over here. There's also named exports. For example, we're importing something from React Native, which is called the app registry, but it has a name inside the React Native module. There are other things as well in the React Native module, which have different names. So we need to identify which part of it we actually want to import. So the app import here should use the default export of this file, and the default export is obviously that one. So it's the provider with a store, a connected counter, which is just an invocation of connect. Let's make double check. Looks okay. Still not work, obviously. Well, the idea was to show you that Redux and React Redux work in exactly the same way in both the browser and the React native environment on your mobile phone. But the illustration doesn't quite work, as you can see. I'm not going to troubleshoot it by now because I'll probably not find the error at this moment. But the thing is, because you run JavaScript on your mobile phone, you can use existing JavaScript libraries that you might use from web development projects or that you just find of use to your project. You can import them in your application by adding them to package.json, and then the Metro bundler will take care of that and ensure that these files are there at runtime as well. I do have another example here, maybe. As I said at the beginning, at the very beginning of this afternoon, my idea was to recreate a game that I watched on television when I was young. That game uses all of the patterns that we've seen until now. So it uses Redux, it uses React Native, and it's open sourced. It's on GitHub. So if you want to check that out, you can. Oh. There it is. If you want to take a look, just take a picture of this so you have both a URL and a QR code. And we can take a quick look at how that code is structured. What we see here is that we have a lot of actions. These actions correspond to things that you can do inside the game. So for example, there's actions adding a new letter to an existing turn. You can give up. You can, for example, have created a word that is not in the dictionary, and you're only allowed to guess words that are in the dictionary. If you have had 5 guesses and you still didn't guess the correct word, you lose the game. And on the other hand, if you did guess it within 5 turns, you will win the game. You can start new games. And all of these have corresponding reducers, simple functions that just create a new state for the whole game as a whole, based on the previous state and the thing that is currently happening. This one. So for example, this is the part where you can see a lot of letters. I mean, the dots where you need to place the letters. You have a text input, and the very moment that you add one letter to it, we invoke a method, and the method will dispatch an action into Redux. This is not an action that's created over here. There's a factory method for that action, but the pattern actually is the same. Let's see if we can run that. Maybe we're more lucky if we try that instead of modifying existing code. Now we need to shut down the existing packager. Native run Android. As you can see, if you do that for the first time, it starts Gradle, and on a different screen, it will start the Metro bundler, which is trying to bundle all of our JavaScript and all of its dependencies. That one's done. Now here it should try to install the app on my device. You might have seen the green bar saying loading from localhost. By default, React Native assumes that you work with an emulator. But if you want to ship an app to your users, it's a good thing to also test it on physical devices. There it is. We can change the URL where the code is being loaded from the development settings. And in this case, we can look up the IP address of the MacBook. Need to see that over here, probably. Yes. That's 192, 168, 43, 290. No, that's not quite what I expected. Well, magic going on. I think the demo gods are not with me today. The idea is that you can use Redux even inside a React Native application, and that way you have a mechanism to prevent your global state from living everywhere in your application. Instead of that, you could keep the state in one global store. The global store will be responsible for mutating it, and it will distribute it to the components that actually need it. As for me, I'm done. There's plenty of time left for questions, so feel free to shoot. I think there's a microphone over there, and otherwise I'll attempt to repeat the question. Are there plugins to use the hardware? Yes and no. They're not called plugins, but you can add modules, and they basically do the same. But depending on the type of hardware, you might need to write them yourself. So you can hook on to Java or Objective-C code. There's a page in the React documentation that describes how to glue JavaScript to either Java or Objective-C. And using the Java or Objective-C, you can obviously do anything. For example, access an NFC reader. There's no native module there's no module inside React Native for that. But you could write that code yourself, expose it as JavaScript functions, and then invoke those JavaScript functions from your code. Does that answer your question? Is there a list of existing modules? Not that I'm aware of. The ones that I've needed so far, I've found just by Googling them. Oftentimes, if you do something like React Native and then, well, the type of thing you want to achieve, you come up with some GitHub project or elsewhere that provides a nice JavaScript API to what you want to do. Any other questions? Question is, how does the performance compare to native iOS or native Android? I assume that you mean, when you say native, writing it yourself in Java or iOS or Objective-C. Yes. Okay. I have no hard figures on that. The UI elements are all native, as I said earlier. Which means that from a look and feel perspective, you won't tell the difference. There is quite a lot of work being done to optimize the runtime behavior. We saw, for example, the set state batching its invocations. There's also some profiling tooling that comes with React Native, so you can spot which components take long to render or take long to update. So at the end, I think there's no hard answer to that. You do get some tools to examine that if you run into issues. And I think you should use those, but only use them in case there is actually a problem. I myself would not use this for high-end graphic games, but I think you wouldn't write them in Java either. You would write them in C and compile against the Android NDK instead of the SDK. Any other questions? If not, I want to thank you for your attention and have a wonderful Devoxx.